So in previous exercises, we have had a certain number of compoundings per year. In the next couple of exercises, we'll be looking at a slightly different situation, where we let the frequency of compounding go to infinity. We say that's continuously compounding interest. And the formula that describes this, if you know the principal, the rate, and the time, you can find the amount using this PERT equation. And you can also, just as we did before, manipulate that equation and get a slightly different version that relates the amount, the final amount, the rate, and the time, so that you can find the initial amount that you would have to invest. So let's say Hannah, back with Hannah again, wants to obtain a future value of $25,800, we know that she would obtain a future value of $25,882 if she had invested her $20,000 inheritance at a rate of 5.19% compounded quarterly. What we want to do is compare that to how much she would have if her interest were compounded continuously. So, let's see what PERT has to say. Our amount would be equal to the principal, still 20,000, times E to, now our rate is unchanged, we're still going to use 5.19% or 0.0519 times T, and we're still looking at a 5-year period. Okay, so if we throw that in the calculator, a lot of calculating in this section, 20,000 times, and you actually have that e to the power button, so we can use that. We're going to do e to the 0.0519 times 5. So in this scenario, if she finds a continuously compounding account with the same rate and the same time, she'll have 25,925. We'll round that to 25,926. So comparing that to the amount that she would have had if she compounded quarterly, we see that she makes a little bit more money. It's not extreme, and the reason is, as we saw before, as the frequency of the compounding goes up, the interest rate, the periodic interest rate, goes way down. So you're going to end up with a little bit more money no matter what if you compound continuously, but it's not going to be very dramatic, at least not for the first few years. Now in the second exercise, we're asked to determine the amount Hannah would need to invest today if she wanted to see her money grow to $150,000 in 10 years at 5% compounded continuously. So in this case, our key word is continuously. That tells us we're going to use one of those PERT formulas. In this case, we want to determine the amount she needs to invest now to make a goal. So that means that we're dealing with the second of those two formulas. The future value formula is not the one we want the present value. Alright, so we know A, just kidding, we know P is equal to A e to the negative RT. Notice that negative showing up again. So what's different? Well, we're trying to achieve a goal of $150,000. So our final amount would be $150,000. Our rate is the same, so we'll have e to the negative 0.05 times t. So now t, we are told, is 10. How long do we have? 10 years at this rate with this final goal in mind. So going to the calculator there, we'll have 150,000 times e to the, don't forget the negative, 0.05 times 10. And again, before you even hit enter, you might want to take a second and think about what dollar amounts would make sense. If we're talking about how much to invest at 5% in order to have $150,000, it's probably going to have to be less than $150,000. So if we hit enter, we end up with $90,979 and 60 cents. Let's round that up to $80. Okay, so if we invest that much now in this continuously compounding account at 5% for 10 years, that's how we're going to get the $150,000 eventually.